The solubility product of the barium sulfate is 1.1 into 10 power negative 10. We have to find out whether the precipitation of this barium sulfate will take place when you mix two different compounds, when you mix barium chloride solution with the potassium sulfate. Okay, so now how we can find the answer? First thing is we have actually we have to find here the concentration of the barium and the concentration of the sulfate ions here. When you mix the two solutions here, and in the solution we have to find out the concentration of the barium and the concentration of the sulfate ions after you mix the two solutions, and from that you can find the ionic product. The ionic concentration of the barium into the concentration of the sulfate. That is what you call as the ionic product. And we have learned in the previous video, we have learned that there when the ionic product of a solution, when the ionic product actually, if it is less than the solubility product, correct, when it is less than the solubility product, then we say the solution is unsaturated, right? So when it is less than the solubility product, that means the solution is unsaturated. It means that you can add some more salt in it and no precipitation will take place. Now if the ionic product, if the concentration of those the barium and the sulfate here, if the concentration of the barium and the sulfate, if it is more than the solubility product, if it is more than this value here, so if it is more than the solubility product, that means the solution is supersaturated, right? It is now the supersaturated and the precipitation will take place. So precipitation only takes place when the ionic product is more than the solubility product. And now if the ionic product is equal to the solubility product, we have learned that it means the solution is saturated. So again, no precipitation takes place here. Precipitation only takes place when the ionic product is more than the solubility product. So our first point here is that we're gonna find out the concentration of the barium and the sulfate ion here. Now actually, if you mix the two solutions here, if we mix the barium chloride with the potassium sulfate, now what are the what will be the concentration of the barium and the sulfate ion in the solution? So let's take it here like this. Suppose we have a beaker in which we mix the barium sulfate chloride and the potassium sulfate. Let's say we are going to add here the potassium sulfate 600 ml. Okay, question is 600 ml of the potassium sulfate is being added, K2SO4, 600 ml, and the concentration here is 0.008 molar, right? So this is the concentration of the potassium sulfate, and we are adding 600 ml. And to this solution we also add some more salt here. We add actually here the barium chloride, right? We're going to add here the barium chloride, BaCl2. And how much barium chloride? We are adding the 200 ml, okay, 200 ml, and the concentration of the barium chloride is 0.004 molar. Now the solution, after you mix the two, after you mix 600 ml and the 200 ml of this one, the total volume of the solution now will be, it will be 600 plus 200, which is now 800 ml, right? Now the solution is at 800 ml volume. So what will be the concentration of the barium and the concentration of the sulfate ion in it? So let's find out first for the this sulfate. What will be the concentration of the sulfate? So we know the concentration is N by V. Concentration is number of moles divided by the volume of the solution in liters, and the number of moles will be equal to concentration into the volume. And here the concentration of the potassium sulfate, we are calculating for the sulfate ion, right? Potassium sulfate. So if you know the concentration is 0.08, so concentration is 0.008 moles into the volume of the solution here is 600 ml, so it is actually 0.6 liters, right? So that will be the, so this will be the concentration, this will be the number of moles here. So the number of moles will be, this is when you simplify here, it will be 4.8 into 10 to the power negative 3, right? This is the constant, this is the number of moles here, number of moles of the potassium sulfate, right? This will be the number of moles of the potassium sulfate. And 1 mole of a potassium sulfate produces 2 moles of the potassium ions, and the sulfate ion 1 mole, right? Okay, that's a 4 2 negative. So that means the concentration of the sulfate ion, the number of moles of the sulfate ion is this much, and the volume, here the solution for this volume after you mix it is now 800 ml. So in 800 mLs we have, this is the number of the moles of the sulfate. So what will be the concentration of the sulfate ion here? The concentration of the sulfate ion here will be the number of moles of the sulfate, which is 4.8 into 10 to the power negative 3 divided by the volume. Volume of the solution now is 800 ml. Okay, so this is 0.8 liters. And again, when you simplify it here, when I am gonna simplify it, so it will be let's say it is now, it will be 6.0 into 10 to the power negative 3, right? This will be the concentration of the sulfate ion. Now what about the concentration of the barium? We have here the barium chloride, and the 1 mole of molecular barium chloride produces 1 molecular barium ion and the 2 molecules of the chloride ion. So now concentration of the, again we're going to use the same formula. Concentration is N by V, and now the number of moles of the barium chloride will be the concentration, which is 0.004, right? 0.004 is the, that is the concentration of the barium chloride. Into the volume we are taking 200 mLs, which means 0.2 liters. So it is it will be 8 into 10 to the power negative 4, right? 8 into 10 to the power negative 4. And now this is the concentration here. This is the concentration, this is the number of the moles of the barium chloride, and this is the concentration of the, this is the number of moles of the barium ions also. Now in 800 mLs, after you mix it, the volume is 800 ml. So the concentration of the barium here, now the concentration of the barium, you can find the concentration of the barium ions here now will be, that is 8 into 10 to the power negative 4, that is the number of moles. By the volume now here is 800 mLs, which is 0.8 liters, correct? 0.8. So it will be 1 into 10 to the power negative 3, right? This is 1 into 10 to the power negative 3. So this is the concentration of the barium ions. And we know the solubility product of the barium sulfate, the solubility product of barium sulfate, here we can write the solubility product is actually the concentration of the barium and the sulfate, and that is this one, correct? This is the solubility product of the barium sulfate. Now let's find out the ionic product here, the ionic product of the barium sulfate. Okay, the barium ion concentration and the sulfate ion concentration, ISO42 negative. So this is the ionic product here, right? So you can find it now. You can use this value here. The barium is 1 into 10 to the power negative 3. This is the concentration of the barium into the concentration of the sulfate, which is 6.0 into 10 power negative 3 here. So this is the sulfate. So when you simplify it, it is 6.0 into 10 power negative 6. And now see, this is our ionic product here, right? This is the ionic product here, the concentration of the barium and the sulfate. When you compare this value here, the ionic product of the barium sulfate, when you compare this one with the solubility product, you see here the solubility product is 1.1 and 10 to the power negative 10, right? So when you compare it here, the solubility product of this is 1.1 into 10 to the power, it is 10 to the power negative 10. So you can see here the ionic product is less, right? Ionic product is more than the solubility product. That means this is a higher concentration here, right? This is much more than what the solution can hold, right? So in a saturated solution you can have a 10 to the power negative 10, but actually here it is 10 to the power negative 6. So since the ionic product is more than the solubility product, that means this condition is there, ionic product here is more than the solubility product. That means this is a supersaturated solution, so precipitation will take place. So which means that when you mix the 200 mLs of the barium chloride 0.004 molar with 600 mLs of the 0.008 molar potassium sulfate, precipitation of the barium sulfate will take place. So some of the barium sulfate will come out in the form of a precipitation, right? This is how we can predict whether the precipitation reaction takes place or not. Hope you got it. Thanks for watching the video. Bye for now.